So hello students. So we were studying about nonlinear programming problem. So till now whatever methods we have discussed, all methods are linked to each other. Like first we started with unconstrained problem, then we studied longer multiplier method which was related to based on unconstrained problem. Then we studied KKT necessary and sufficient conditions, corresponding necessary and sufficient conditions which were based on Lagrange multiplier method, and then we studied Wolf's method which was based on KKT's sufficient condition and necessary conditions. Now we will study one more method, we call it Beale's method. So in different videos or different places you will find different pronunciation for that. But today, this method is not based on any of the method which we have studied till now. This is a completely different method, and so we will start it from the beginning. Okay, this method is used to solve quadratic programming problem. Introduction of quadratic programming problem we have already studied about that. So let us see. So we will directly solve one problem based on Beale's method, and within the problem we will see its algorithm. So this is the problem. This is a quadratic programming problem. You can see here. The first part is a quadratic form, and this part is linear, and all the constraints are linear, and non-negative restrictions are there. So we can say that this is the problem is already given in the form of quadratic programming problem. It is already in the standard form because the problem is already given in the maximization form. If it is minimization, we can multiply the objective function by -1 and then we can convert it to maximum form. But it is already in the maximum form. Constraints are given in the ax less than b format. Okay. Now what we do? We started. So we will relate on some places. We will relate this problem with the simplex method just for memorization purpose, so that we can remember the method properly. But this method is not connected with any other existing method which we have studied. Okay, so we convert this problem into some other form where this equation is converted, this inequality is converted in the form of equality. So we write it such that x1 plus x2 plus x3 is equal to 2, and x1, x2 and x3 all are given 0. Okay. Now inequality, the constraint, main constraint that is given to us, we converted it in the form of equation. Okay, objective function will be as it is. Right. Now what we do, like simplex method, here also we first find initial basic feasible solution. So initial basic feasible solution. So how many constraints are there? There is one constraint and there are 3 variables. So number of variable in a basic vector will be just 1. Okay. We can take any variable as a basic variable, but we prefer it. We will make it decision variable because x1 and x2 are decision variable. x3 is select variable. So in this method, we just try to make it the decision variable. Okay. So now this is the basic variable. So basic variable is x1. So we will give full value to the basic variable, that is 2. And we see that the non-basic variable is always 0. So x2 is 0 and x3 is 0. So I am repeating this here. There are one constraint, there is one constraint, and there are 3 variables. So number of basic variable will be just 1, and the value of the non-zero variable will be 0. So x2 and x3 are 0. So therefore x1 is 2 to satisfy this equation. Fine. Now what we do, we we get this in the form of, so this constraint can be written as x1 equal to 2 minus x3 minus x2 and minus x3. Okay. Now we write our objective function in the form of non-basic variables. Now step 2 जो है, next step क्या है? objective function in the form of non-basic variable. In the form of non-basic variable. So using this equation, we will put the value of x1 in our objective function and then we will write the objective function in the form of non-basic variable. So z will be minus 2 x1. What is the value of x1? 2 minus x2 minus x3 star plus 2 minus x2 minus x3 and then x2 minus 2 x2 star plus 6 2 minus x2 minus x3. Right? Now what we do, we differentiate this function with respect to its variables. So its variables are x2 and x3, so we will do partial differentiation with respect to x2 and x3. So del f by del x2 equal to, so we get here 4, so it will be 4 2 minus x2 minus x3 plus, so we will get here 2 minus x2 minus x3 minus 2 x2 minus 4 x2 minus 6. Okay. Similarly, del f by del x3 can be written as same way 4 2 minus x2 minus x3 star plus x3 minus 2 x2 minus 2 x2 and then we'll write here minus 6. Okay. Okay, so we will put the value of this point on this differential. Okay, so value is x2 is 0 and x3 is 0. So we will put x3 0 and x2 0 on these both of values and we will see what we get. So if we put 0 0 0 0 and here I put 0 0, then I will get, so all of these values will be 0, so 12, so I will get 6 here and here I will get 2. Okay. So at the point 0 0 we get 6 and at the point we get 2. Okay. Now I will go to a little bit of analysis here. Okay, so if I write df by dx and if I get it positive, what does it mean at some point? Let's say some point x0. What does it mean? At this point, if x is increased, then f will be increased. If x is decreased, then f will also be decreased. Okay. So similarly, since we are at this point, we are getting the value which is positive, and both of them are positive. It means if I increase the value x2 here, then my objective function will be increased. In both of the cases, similarly, if I increase x3, my objective function will be increased. But what we want to maximize it. So we want to keep it at the highest speed. Okay. So therefore, we decide to keep x2 as a basic variable so that x2 can be given a non-zero value. Fine. So now, since now we include x2 in basic variables. Now we include x2 in basic variable and x3 will be adjective. So x3 will be 0. Okay. Now let us see at this equation if x2 will be given a non-zero value and so how much value x2 can be given. So since we want to make it maximum, we will make it 0. Okay. So they have ideal x2 equal to, now whatever the equation I will get, I will write it down. So I am getting equation 6 minus 12 x2 minus 6 x3. Now if I simplify this expression, I will get this. Fine. Since I want to maximize the speed of increasing, I will keep it 0. Okay. So I will keep it 0 and x3 is also 0. So putting x3 is 0, we get 6 minus 12 x2 is 0 and x2 is 1 by 2. Okay. Now x3 is 0, x2 is 1 by 2. So x1 will be here 3 by 2. So therefore it gives me x1 equal to 3 by 2 5%. Now there are two variables which have non-zero value. Okay, but it should not be there when there is constraint is just one. So what we do, we add one more constraint and we call it dummy constraint, so that our condition is satisfied that there must be at least two constraints for being two basic variables. Okay, so what we do, we make one dummy equation, we write it down. So I will name it as S. So S is a new variable I included in the problem, minus 6x3. Now since the value is 0, the value of S is also 0. So S is 0. So since it is 0, it gives me 0. Okay. So what is my solution? Basic feasible solution. Basic feasible solution. x1 is 3 by 2 and x2 is 1 by 2 and x3 is 0 and S is. So this is my basic feasible solution and I have two constraints. One constraint is given here and another constraint is given. This is my another constraint. Right? Now we will repeat the process. So what we have done here, we have written the basic variable in terms of non-basic variables and then we substitute the non-basic variable in the objective function and then we differentiated the objective function with respect to its variables. Okay. So we will do the same again. So friends, what we have done till now is that in the next step we will write the basic variable in terms of non-basic variables. So here basic variable are x1 and x2 and non-basic variable are x3 and s. So first we will use this equation. So we will write x2 in terms of s and x3. So what we have done, we have taken x to one side and s will go there, right hand side. So we have written in this form 6 minus 6x3 minus s divided by 12. Now we will use this equation to get another equation. So we will substitute the value of x2 in this equation. So x2 is given in x3 and s form and x3 is already there. So x1 will be 2 minus x3 minus the value of x2 in this form. Okay, so finally we got these two equations. So I can write this equation number 3 and this equation number 4. Okay, so what we do, now we substitute these values in our objective function so that my objective function becomes in the form of non-basic variables. So substitute it here and we got this expression here. So we see here that so value of x2 and value of x1. So value of x2 and value of x1 is substituted. Fine. Then we differentiate it with respect to x3. So it will be given in this form. And finally we substituted the value 0, 0 and we got minus 1. Similarly we differentiated with this expression with respect to small s. And we got this expression and when substituted 0, 0 we got 0. Now it means that if I make x3 as basic variable, the value will decrease and this is what we don't want. Okay. differentiation of f with respect to s is 0. It means if I include s in the basic variable, the value of the objective function will be as it is. So that is also not preferred. So what does it mean? It means that whatever the solution we have till now is the best solution. It is the optimal solution. So this solution finally we got optimal solution. Okay. So now I am repeating the process one more time. We are revising it. The objective function is given to us. The constraints are given to us. Step 1. In step 1 we convert the problem into the standard form. So objective function should be in the maximizing form and constraint should be linear form, ax less than b form. Okay. Then we introduce slack variable or surplus variable to make the equation form. So we convert the constraint in the equation form. So this is the standard format. Fine. Now depending on the number of constraints, we choose our basic variables. Now in this case, you can take any basic variable, there is no problem, but the number of basic variables should be equal to the number of constraints, provided that the variables is higher in order. Okay. Then we substitute, run from the constraints itself, from the equation itself, we write the non-basic variable in terms of we write basic variable in terms of non-basic variable. Then we substitute the value of the basic variable in the objective function, so that objective function become in the form of non-basic variables. Okay. Then we differentiate the objective function with respect to all of its variable, which is non-basic variable, and we put the value 0, 0 because the value of non-basic variable is 0, 0 at that step. So we get 0. So whatever, so then we get the value of the differentiation, like we got these two values here. Now we judge it whether if we include these non-basic variable in basic variable, then what will happen? Whether the objective function will increase or decrease. So if the differentiation is positive, it means we should include that variable in the basic variable. Otherwise, we should not include. Okay. So if positive, then we include it in the basic variable, keeping the another non-basic variable as 0, because at one step we will include exactly one variable in the basic variable. We will not include two variables in just one step. Okay. So other non-basic variable will be 0. The main basic variable, we will just include one basic variable. So one should come out. If it doesn't come out, with the help of constraint, we will see whether the another variables are becoming 0 or not. If it is not becoming 0, it means that we have to add one dummy constraint. So that respective differentiation, we will make itself as a dummy constraint and we include it in the problem. And we repeat the process. Again, we write non-basic variable in terms of basic variable in terms of non-basic variable, and we change the objective function in form of non-basic variables and differentiate it one more time. That is the method. Thank you.